Hello everyone. In the last video, we have already seen the overview of convolutional neural networks. In this particular video, let's try to go into the details of this particular CNN. So if you guys remember, the first layer in CNN is the convolutional layer. And what is it responsible for? It is responsible for extracting out features from the input image. Let's try to understand how it will extract out features. In order to do that, let's try to take some simple example in which we'll be having images which contains X, and also we'll be having images which contains O. So we need to identify whether the given image is having X or O. So this is very simple binary classification task. On this task, we need to apply CNN and finally get the output, whether it is X or O. In order to solve this, first we'll be applying this convolutional layer. And as I said, in convolutional layer, we'll try to extract out features. If you guys remember, if we are given an human face, what can be the possible features? So let's say this is our human face. On this human face, you can identify multiple features like this ear can be one feature, eye can be one feature, nose can be one feature, teeth can be one feature, hair can be one feature. All these are different features, right? Similarly, in case of this particular image also, that is X and O also, there should be some corresponding features related to this particular shape. And the corresponding feature can be something like, for this X, some kind of slant line like this can be one feature because it is present over here, right? And similarly, this kind of shape can be one feature which is present in this middle part. And similarly, this is already covered, so the other slant line can be other feature. Like that, these can be the possible features for this particular X shape. And similarly for O also, there can be multiple features, like this can be one feature for this O shape, and similarly this can be another feature, and similarly this can be another feature. Like that, these are all features that might be related to this O shape, and these are all features that might be related to this X shape. So if we can find out whether these features are available in the input image or not, if we can find that, then we can clearly tell that whether it is a X shape or O shape, right? So that is what we'll try to extract out from the convolutional layer. We'll try to see whether this feature is present in the input image or not. And similarly, this feature is present in input image or not. And similarly, this is present in input image or not. And also for all the features that we have, we'll try to observe this. That is whether the given feature is available in the input image or not. Let's try to see how we can do that with the help of convolutional layer. Before exactly going on to this convolutional layer, let's try to see how image is getting represented in case of numbers. So let's say if we are having X on the input image, that X can be represented with pixel values, and the pixel values can vary from 0 to 255. But for simplicity, let's take the pixel values wherever like it is active, like wherever it is clearly seen over here. There, let's say the pixel value is 1. So here we are able to see something, right? Some shape. There, let's say it is +1. And wherever we are not able to see anything, there, let's say it is -1. So I'm taking this +1 and -1 so that it will be easy for me to explain. But the operations will be the same in case of numbers as well, or the exact pixel values as well. Now let's take +1 and -1. As the X shape is like this, so for this kind of shape, wherever this particular thing is present, there it will be represented with 1. That is, in diagonals, it will be 1. So if it is like this, then only we can show some X shape, right? And remaining places, wherever nothing is present, there we'll be representing with -1. We might be seeing the input image as X, but the model will be seeing it in case of numbers. And these are all the numbers that are getting represented. Okay. Now let's try to understand how we can extract out some feature from the given input image. So this is our input image, and on this input image, we need to extract out feature by applying convolution operation. In convolution operation, we'll be having something called as kernel. The kernel will be smaller when compared to the input image. Let's say the input image size is 5 cross 5 over here. The kernel size is 3 cross 3. And let's say the feature that the kernel is representing is this one, this particular slant line. In order to represent that this slant line like this, we need to keep values in this diagonal, and in remaining all portions we need to place -1. This particular kernel, that is 3 cross 3 kernel, is representing this particular slant line. Now let's try to see how we can apply this convolution operation and extract out this kind of slant line information from the input image. Basically, in convolution operation, what we'll be doing is we'll be placing the kernel. So here, this is our kernel, right? So this kernel will be placed on the input image. That is, it will start from this particular starting point, and it will cover 3 cross 3 portion. As the size of this is 3 cross 3, it will exactly cover the 3 cross 3 portion. And as it is covering this 3 cross 3 portion, what we'll be doing is, on this we'll be applying the convolution operation. And in convolution operation, what we'll be doing? We'll be doing element wise multiplication, and then we add everything. What is element wise multiplication? I'll explain you clearly over here. For this one and this one, element wise multiplication is like, we'll take this one and we'll take this -1 and we'll multiply. And then, as I said, we need to add all these multiplications. So 1 and -1 plus -1 and -1, that is -1 is getting multiplied with -1. That means there is a match in the pixels, right? So whenever there is a match, the multiplication will give us 1, and whenever there is a mismatch, it will be giving us -1. So that is what we can observe from this. So here also there is a mismatch, so it will be -1, and here there is a match, so it will be +1, and here there is a match, again it is a +1, and here there is a match, so again it is +1, and here there is a mismatch, so it is -1. Here there is match, so +1, and here there is a mismatch, so -1. So like this is, let me replace this is -1 and this is +1. Okay, like this, these are all the values that are available by doing element wise multiplication. Now the +1 and -1 will get cancelled out, right? Like that. On cancelling out, we'll be left out with 1. Total will be getting the value to be 1, and we can do average also. So by this, as the total number of values are 9, we can do something like by 9. And now in the output, we'll be placing this particular 1 by 9. 1 by 9 is the value that we'll be getting by applying convolution operation one time on the input image. And after applying this convolution operation for once, what we'll be doing? We'll be moving the kernel. So this is the kernel that is placed over here, right? So now we'll move the kernel by one column. After moving it by one column, now we'll be placing the kernel over here, and it will be covering 3 cross 3 from this point. And again, we'll do the same operation, that is element wise multiplication, and then we add. So let's see how many are matching. So here there is a match, and here there is a match, here there is a mismatch, and here there is a mismatch, and here also there is a mismatch. Sometimes I might miss, so let me write down over here. -1 into -1, that is 1, and then -1 into -1, again 1, and then -1 into 1, that is -1, and then 1 into -1, that is -1, then -1 into 1, again -1, and 1 into -1, again -1, -1 into 1, that is -1 into 1, that is -1, and 1 into -1, that is -1, -1 into -1, that is 1, +1. So here if you observe, if we cancel out, 2 -1s will be gone and these will be gone. So we'll be left out with -3 overall by 9. This will be -3 by 9. And then again we'll be moving it by one column. First we started over here, and then we did convolution from here. Now we'll do convolution from here. Okay, start over here, and we'll do the same operation, that is doing element wise multiplication with this. So here if you observe, all the pixel values are exactly matching. Here it is -1, and here also it is -1, here minus 1 and minus 1, 1 and 1, minus 1 and minus 1, 1 and 1, and again minus 1 and minus 1. Here also it is matching, here also it is matching, and at last here also it is matching. So that means that all these values will be 1 in this case, 1 plus 1 plus 1 plus, like that 9 times we'll be getting 1, and finally divided by 9, what we'll be getting? We'll be getting 9 by 9, which is 1. Okay, so that means that whenever there is an exact match with this particular kernel, then it will be giving an output of 1, and whenever there is a complete mismatch, then it will be giving us minus 1. Let's say in some position there is a complete mismatch for now, so it will be difficult for me to explain for each and every box. So let's say in this box there is a minus 1, that means there is a complete mismatch. So whenever there is minus 1 over here, in that portion it is filled with plus 1 in the input image, and similarly whenever there is a plus 1, here it is filled with minus 1. Like that, if there is a complete mismatch, then it will be minus 1, and if there is a complete match, then it will be plus 1, and any value between minus 1 and plus 1 is like there is some particular match. So if the value is going near to minus 1, then we can say there is more match with the kernel that we are having. And if it is near to minus 1, that means that there is a more mismatch. So like that, the information about this particular kernel is signified after applying this convolution operation. Okay, so here the input image is 5 cross 5, kernel size is 3 cross 3, and the output shape that we are getting over here is 3 cross 3. And how we are getting 3 cross 3 over here? That is because first we'll be applying the convolution operation over this part, and after that we'll be moving by one column, right? So after moving by one column, here it goes till here. Okay, and after that again we'll move by another column. That means first we are starting over here, and after that we move by one column, we are starting over here, and after that we are moving by one column, we are starting over here. And by this time we have covered all the columns, right? So we covered till the last column. Again, if we start from here, there is no third column to cover, so that's why we'll not be able to get another output in this particular row. I hope you guys are able to understand this, because from here we are only able to cover 3 columns. After that we can't cover 3 columns if we start from over here, but in the kernel there are 3 columns, right? So that's why we'll be getting only 3 columns in the output. So this 3 columns, I hope you are able to get how we are getting it. Once we came till this last point, then what we'll be doing is we'll be moving by one row down. Again, we'll start the convolution operation from this point. We'll start from here. Initially we started over here, right? Now we'll start from here, and again we'll do the same operation, and we'll be getting the output that we'll be placing over here. And after that again we'll move by one column, and we'll cover this portion, and we'll be placing the corresponding output over here. And then like that, completely, after applying the convolutional layer, for the given kernel we'll be getting an output of 3 cross 3. So if we generalize these numbers, if it is n cross n and this is k cross k, then what will be the output shape? So simply we can understand this. If we are coming till this portion, that is, let's say if we are numbering 1 2 3 4 5, if we are coming till this 3, then we should stop, right? That is 5 minus k. What is 5 minus k? 5 minus k is 2, but we need to cover extra one, that is 5 minus 3 plus 1. If this is n cross n and this is k cross k, then it will be n minus k plus 1, n minus k plus 1. This will be the corresponding output shape. Given an input image of n cross n and the kernel size is k cross k, on applying convolution operation, we'll be getting an output of n minus k plus 1 cross n minus k plus 1. I hope for you guys it is clear how we are able to get this output of n minus k plus 1 cross n minus k plus 1. If you are having any kind of doubts, please comment down in the comment section. I'll try to make another video on that, and I hope it is clearly understandable how this convolution operation is extracting out features. So let's say in this kernel it is representing about this feature like this. So if in the output the value is exactly 1, that means that it is an exact match where this particular slant line is present in the input image. So in this portion of the input image, there is a slant line like this. And similarly, when there is an exact mismatch, then we can say that this kind of line is not at all present in this portion. Like that, it will show the information how good it is matching with this slant line that we can get from this particular output feature map. Okay, I hope this video is clear. Like, we'll see what is ReLU in the next video, and for now that's it. Thank you everyone. Bye bye.